Final chapter in section 7 or chapter 7, final section is 7.8, which is factoring completely. If you are somebody who enjoyed the factoring by grouping technique, you will find this section to be pretty straightforward here. So let's take a look at this. So to factor a polynomial with 4 terms. So now everything we've been seeing so far has been a polynomial like trinomial, 3 terms. Now, when we factored by grouping, we broke up that middle term to create 4 terms, okay? So these polynomials that we're going to be looking at here are going to have 4 terms to start with. We're going to break them up into pairs like you would when you were factoring by grouping, factor out the greatest common factor, and then go from there. So if you liked factoring by grouping, you're going to say, oh, this is pretty easy. So let's take a look at this. So notice here, it's already 4 terms here. So what we're going to do is we're going to say, okay, let me group them. So I'm going to group the first 2, and I'm going to group the last 2. And we're looking for the greatest common factor, okay? So it's important that you're strong in that particular concept. So if I'm looking at x cubed and 3x squared, obviously there's no number that's common between them besides a 1, okay? So I could take a 1 out if I wanted to, but I can take x squared out of both of those because I have an x cubed and an x squared. So I'm going to take x squared out. If you want to put the 1 in front of that, you can. If I take x squared out of x cubed, I factored it out. All I'm going to be left with is an x, because x squared times x will get me back to x cubed. I've taken x squared out of 3x squared, and all I'm left with now is a 3. And I could check that by doing x squared times x, that is x cubed, and x squared times 3, that is 3x squared. Now I look at my second set of parentheses and I say, what can I take out of there? So I'm looking at 2x and 6. So I say to myself, what is the greatest common factor? Well, I can pull a 2 out of both of those. So I'm going to put it as a plus 2, because it's a positive 2 I'm pulling out. If I take a 2 out of 2x, I'm just going to be left with x. If I take a 2 out of 6, I'm going to be left with a positive 3. If you have done things correctly when factoring by grouping, this set of parentheses and this set of parentheses must match. They do, okay? So how do I write my final answer here? Well, what I've factored out, right, is technically an x plus 3. So now I'm going to write that first. This is going to be first. Doesn't matter the order. And then what are you left with? You're left with here x squared plus 2 as your other set of parentheses. And there's your final answer. So again, group the terms. First 2 terms, second 2 terms. Take out the greatest common factor, rewrite it, and then combine. So here, this one's a little bit weird, especially in the first part. X squared and y don't really have anything in common, right? They both don't have an x, they both don't have a number. So we're going to just pull a 1 out. So I'm going to take a 1 out. And I'm going to be left with x squared. Oops, you know what I'm going to do actually? Sorry. We should rewrite it, because then we can pull something out. You always want to rewrite it with your x's first and then your y's. So I'm going to rewrite this as x squared plus x plus xy plus y. Because there would have been nothing I could pull out originally, but now there will be stuff I could pull out. So now I'll group them. So in my first set of parentheses, I can take an x out of this, and I'll be left with inside x times x will get me x squared plus 1. Then my second set, I can take a y out. So I'll take a y out. Y times x will get me xy, and y times 1 will get me y. Notice now, once again, these match, which they need to. So there's my one set of parentheses, x plus 1. My other set comes from the outside, and it'll be x plus y. And there's my answer. So we're factoring by grouping, which we should have some experience with, okay? We will look at several more examples in class. I look like that, but now let's move on to this one. Now, we say to ourselves, okay, I have to factor this completely. So the first thing that you want to do when we're dealing with these is you want to look for a greatest common factor. So we're back to a trinomial here, and I say to myself, wait, I can factor something out of here. I can take a 3 out of all of these, because 3 goes into 3, 6, and 18, and I can take an x out. So I'm going to take a 3x out of all these. Then I'll just be left with x squared plus 2x minus 6. Now, unfortunately, this part right in here is not factorable. Okay, so maybe fortunately for you, because that's the end of the problem. There is nothing that multiplies to negative 6 and adds to 2. If I think about factors of negative 6, right, I can have negative 6 and 1, that's not going to work. 6 and negative 1, that's not going to work. 3 and negative 2, that's not going to work. Negative 3 and positive 2, that's not going to work. Nothing will work here. None of these are adding up to 2, my middle term here. So this is actually your final answer there. An easy one. Now, here's one that's not as easy. Take the greatest common factor out of here. So I can take a 7 out of both of these, because 7 can be divided by 7, as can 28. And I can take x squared out of both of these. So take x squared out, and you'll be left with here x squared minus 4 in parentheses. This, unfortunately, for you, is factorable right here. So this now is the difference of squares, what we saw in section 7.7. So x squared is a perfect square, so is 4. This is going to factor to 7x squared on the outside, x minus 2 times x plus 2. And there's my final answer there. So it's all dependent on whether or not that thing, that second part is factorable. Sometimes it is, sometimes it's not. We'll go through these in class. This one is asking us to solve. So not just to factor, but to solve. So in order to solve, we need to set it equal to 0. So let's start by subtracting 10x. So then we've got 2x cubed plus 8x squared minus 10x is equal to 0. Find the greatest common factor. What can I take out of all these? I can take a 2 out of all these. I can take an x out of all these. So take that 2x out, and now you're going to be left with x squared plus 4x minus 5 is equal to 0. Let's factor. Factor in here. Need to come up with something. This is at least the easiest type of factoring, right? Needs to multiply to negative 5 and add to positive 4. So hopefully you're saying to yourself, positive 5 and negative 1. So let's write that then. 2x times x plus 5 times x minus 1 is equal to 0. That is the correct factored form. Now you need to solve. So I have to set this equal to 0. I have to set this equal to 0. I have to set this equal to 0. One of my solutions here, divide by 2, you're going to get x is equal to 0. Here, subtract 5. You're going to get x is equal to negative 5. Here, add 1. And you're going to get x is equal to positive 1. All of these are your solutions. You have 3 solutions here. X equal to 0, x equal to negative 5, and x is equal to 1. You should feel a sense of accomplishment when you do a problem like this. We'll look at plenty of examples in class on factoring completely, as well as the word problem that follows here. Okay, if you want to take a look at them ahead of time, feel free, but they are challenging. Good luck. See you in class.